Hi guys, here to talk to you today about Aero-IMPACT 2.0. It's the technology that we've been working on for the last 4.5 months, and we're releasing it today. And we basically want to go through what it is and what it means for you. So Aero-IMPACT 2.0 is a massive step change for the performance of the Seed Terminator. We're talking about a reduction in power of 31%. We're talking about massive improvements in wear life, and really it's come about by brute force. We've done a heap of testing, tried different prototypes, tried all sorts of different ideas, and come up with something that we can finally jam into our MY8 model year 18 production and roll out this year. So I just wanted to go through some of the features and what it is. So diving into the details, the tungsten carbide coating, we've engaged a surface engineering company. We're working really closely to do a lot of R&D in this space, and it's all about how do you strengthen the weakest link in the chain. So if one part's wearing out first, then everything is limited by the wear life of that part. So we're trying to reduce the weakest links in the chain. We're also, I haven't put it here, but we're also optimizing the particle flow within the mill so that we're not wearing out certain parts faster than others, and that further improves our wear life as well. So that's that piece. The power reduction and kill, we've basically the power of the Seed Terminator is broken into three main parts. I love a good equation, by the way. Power total equals the power of the drive plus the power to run it empty, which is the no load, plus the power to process. You'd think I could get a decent texter. Anyway, so the drive power, reasonably obvious. Any losses within the drive are additional to add to the total power of the milling machine. So we've always focused really hard on minimising this mechanical drive system. We only have belts, gearboxes and shafts. Our gearbox is German manufactured and it's really precise, so it doesn't generate much heat, has no cooling system. It's just really efficient. So we've minimised this. The no load power is interesting. This is the one that's it's basically the air pumping power. So if it's running empty, then there's air going through, and that air is being accelerated by the mill, and that creates a certain amount of power. It's an interesting one because we actually want to pump a lot of air so that we're not affecting the harvester sieve. We're creating a suction, but we don't want to be wasteful in that in doing so. So there's a useful part of this, which is the pumping of air. There's a non-useful part, which is generating turbulence. Turbulence dissipates as heat, which is wasted energy, and that can be really significant. And the last part is the processing power, which is the useful power. So this is the amount of power that actually goes into the chaff to destroy seeds. Now, we knew from the outcome of the 2017 harvest that we're certainly over processing the material. There's you can't even really see the seeds as they come out. They're flour really, and that in some circumstances that's a good thing to do if the say that the weeds are a bit higher moisture, they're smaller, a bit harder to kill, then that's great. Also, if you've windrowed your crop and you've got all the seeds in the row and they're all going to end up in the harvester, then it potentially makes sense to over process the material. I know we had one farmer from Lucendale, he is really excited because he had some windrowed barley that he got it was quite weedy, and he got all of the weeds into the front, and he just can't find them germinating this year, which is a massive outcome, and I didn't even think was possible in high weed burden areas. But I guess that, you know, that sort of scenario makes a lot of sense. But we knew that we've got some potential improvement here. So I'll just talk about the no load power first. So we've improved this with the Aero-IMPACT 2.0 by implementing some new CNC manufacturing techniques, and that's enabled us to create better geometry that's going to create less turbulence. So our impact bars are now fully smooth, which means that the separation of the streamlines going past the impact bars is further back, which means less drag, less turbulence. And the processing power we've toned down by doing a whole heap of prototyping. So we've tried so many different screens and different configurations, and basically tried to understand where the tipping point is. And we've recently got the germination results out of the University of Adelaide, and found that for our setup that achieved 31% reduction in power, we're still able to get really high levels of annual ryegrass seed kill. So we basically set on that. We know that we can improve in the future, and we'll continue to do so, but that's where we're at this year. 31% reduction in power, really high levels of kill, improved no load performance as well because of the improved geometry, and we've coated it all in tungsten, and I'm really excited for this year's harvest. So processing power first is equal to some function times n squared. So if you change the speed, if you double the speed, you get 4 times the amount of energy going in to the chaff material. So it does ramp up quite quickly the amount of processing energy and effect you have on the chaff and weed seeds. This function here is all about the geometry of the mill, and it's all about how long the material stays in the mill, or residence time. So increase the residence time, you increase the amount of processing, the kill goes up. The problem with this is you increase the residence time, you reduce the capacity. We know from 2017 that we were over processing, so we had an opportunity to reduce the residence time in the mill. So we've reduced this function. By reducing the residence time, we've increased the capacity, so we've been able to reduce the speed a little bit as well, and that's overall reduced our processing power quite a bit. We haven't done it too much. As you can see, we've still got really high levels of seed kill, but it's given us more capacity, lower speed, and less energy used. The no load power is proportional to some other function, but this time it's to the power of 3. So if you double the speed, you get 8 times as much energy going into the air, which is quite significant. So you only need to change the speed a little bit, and you reduce the no load power by quite a bit. So by us tweaking the residence time to get better control of the processing power and reducing the speed, because we've got better capacity, we're able to reduce the no load power through this equation here. The other improvement in no load power is all about our geometry. So our geometry looks a little something like this. It's not a very good picture. And basically we've improved the machining on these surfaces. to have attached streamlines as they go past. So we still have turbulent weight, but it's more attached and our coefficient of drag is reduced significantly. And all you need to think about here is how much cars have improved in fuel efficiency over the years. The old square body cars didn't pass through the air anywhere near like new cars do, and that results in much more fuel use for those square shaped cars. Same thing here, reduced drag, less turbulence. That's turbulence turns into heat. So the closer these two can be together, the better we are.